Surds. Okay, now people hear the word surds and they know about them and they get scared. Surds are not scary. So surds are irrational roots of an integer. Integer just means whole number. Okay, so I've got two examples here. Square root of 2. Now square root of 2 doesn't come out perfectly. He's going to equal 1 point something. Because he's going to equal a decimal, that is a surd. Okay, we don't want to write that decimal. It's like when you have a fraction. If I have, 2 on 19, that's going to equal some horrible decimal. I don't want to be writing that out, so I use the fraction 2 on 19. I don't want to write out the horrible decimal that square root of 2 is going to be, so we're going to leave him as square root of 2. Square root of 4, I can do that one. That equals 2. So that is not a surd. Square root of 6, well, he's not a perfect square, so that one is a surd. Square root of 16 equals 4, so he's not. Square root of 100 is 10, so he's not. Square root of 210. Bit harder, but that one is a surd. So we want to be able to identify surds. Once we identify surds, we then want to be able to simplify them. So there's a couple of ways to do that. We can do it by recognition. It's by intuition, recognition, inspection. That's a good word. Inspection. Okay. Inspection involves you knowing your first few squares. Okay, and then trying to see if this can be divided by any of your squares. So I know I can rewrite root 12 as root 4 times 3. So root 4 is my square number. I want one in there. If I haven't got one in there, then it's not going to work. Alright, so I can then rewrite that as root 4 times root 3. And what is the square root of root 4? Sorry, what is the square root of 4? 2. So this one becomes 2 root 3. And that is our simplified version, because we can do more things with it if we have it simplified. There's another method, which is your factor tree. Okay, with a factor tree, what we do is we think, well, what are our prime numbers, and what is the smallest one I can divide 12 by? Smallest prime I can divide 12 by is 2, which gets me 2 times 6. Then we do it again. What's the smallest prime number I can divide 6 by? 2, 3. So you want all the ends of your tree to be prime. So 2, 2, and 3, all prime numbers. Perfect. Then what we do is your pair is your whole number. And whatever's left by itself is your surd. So because I've got a pair of 2's, that means 2 is my whole number. And then I have the 3 by himself, so it becomes root 3. Alright, 45. So once again, I can do it by inspection, or that one becomes root 9 times 5, which becomes square root of 3 times, square root of 9 times square root of 5, which becomes 3 root 5. So that's my inspection method. With my tree, I would start with 45. Smallest prime is 5 that I can think of off the top of my head. 9, 3, and 3. So they're all primes. Beautiful. Here's my pair, so that becomes my whole number. This guy's lonely, so he becomes my surd. So 2 different ways to get there. So 230. Can we simplify it? Don't know. I can't easily recognize a square number that I can take out of 230, so I'm going to go straight to my factor tree. 230, well that's 2 and 115. And then obviously 5 comes out of him, which is 23. And they're all prime numbers. Because I've gotten to prime numbers and I have no pairs, he cannot be simplified. That means he stays as root 230. And that's what we do. Alright. We also want to be able to add and subtract and combine our surds in different ways. So with this one, we can literally think of it as 2x plus 3x. If I have 2x plus 3x, that's just 5x. So we deal with surds the same way. 2 square root 2's plus 3 square root 2's equals 5 square root 2. You have to have them the same. If I had 2 root 3 plus 3 root 5, that's it. I can't go any further because that'd be like saying 2x plus 3y. That's it. I can't go any further. So your surds have to be the same for you to be able to add and subtract them. All right, here, 4 root 2 minus 1 root 2, 3 root 2. Nice and easy. If you have two surds multiplying together, you can just put them both underneath your square root and then simplify. So that one becomes root 10. Easier to have one surd than two surds. So we want to be able to add these two together, root 18 and root 32, but they are not the same surd, so I can't add them together. But I can simplify them first. So that's 9 times 2, 16 times 2, so I'm doing it by inspection. And then we can add them together because now they have the same surd. So root 18 plus root 32 is 7 root 2. Easy. Okay, we always want to rationalize your denominator. We don't like having surds, we don't like having surds on the bottom. So what can I times root 6 by to get a whole number? I times it by itself, because root 6 times root 6 is root 36, which is just 6. Perfect, we get rid of him. And whatever I put on the bottom, I'm going to put on the top, because root 6 on root 6 is like saying times by 1, because that is the same thing. So then I have 2 root 6 on top, 2 root 6. And then if you can cancel anything out, do it. So I know I have 1 2 in 2 and 3 2's in 6. So my final answer is root 6 on 3. Alright, have a go at the Surds worksheet. It's up the top in the resources section. I will upload answers.